Okay, so we're on page 191 of the notes, and we're going to do two sample proportions for confidence intervals. Very similar. Our formula is going to change. And so the purpose is a two sample Z interval for proportions, because once again, if we're working with proportions, it'll always be a Z, so that makes things easy. We don't have to worry about the T. So two sample Z interval for proportions is used to create a plausible range for the difference between proportions of two independent populations. All right. And as always, we have the estimate plus or minus the margin of error. Right. The estimate in this case is the difference between the two sample proportions. So our best estimate is going to be p hat 1 minus p hat 2. You'll see that in the formula in just a moment. And then we have a margin of error. So basically, this part right here, the p hat 1 minus the p hat 2 is our estimate. And everything that follows the plus or minus is the margin of error. So the part to the right, so beginning with Z star, is the margin of error. And then the radical, the square root part, is the standard error. So the standard error is just the square root. And you'll notice, and for comparison purposes, I'll write out the one sample. One sample was p hat plus or minus Z star, p hat, q hat, n. So basically, we just have, all we did was subtract another p hat. And then since we have two, we have to add another one. And remember, the reason it's adding is because you cannot subtract standard deviations, all right? So you cannot subtract standard deviations, so they have to be summed. Okay, so basically, you can read that page, but it's very similar to what we've done before. As far as our recipe for success, because you have two populations, you have to define P1 and P2. Please note this is the population proportion of 1 and the population proportion of 2. This is not P hat 1 and P hat 2. We need to write the conditions, and we're going to have to do it for both. All right, we're going to have to do it for both. And everything else is going to run very much the same way. So let's go ahead and begin our first problem. A grocery store manager notes in a simple random sample of 85 people going through the express line that only 10 paid with checks. In a simple random sample of 92 customers passing through the regular line, 37 paid with checks. So basically, we have two groups. We have those who are going through the express line and those who are going through the regular line. Construct a nine, and by the way, just personal comment, do not go through the express line and pay with a check. I mean, I know no one pays with checks anymore, or very rarely does it happen. Don't pay for a check in the express line, and don't count coupons in the express line. Go to the regular line. Take someone else's time. If I'm in the express line, I don't want to be behind you and your coupons and your checks. Next thing, construct a 95% confidence interval for the difference. By the way, that was just for free. So construct a 95% confidence interval for the difference. And I'm going to go ahead and take a moment and say, when we're doing this, it helps, not required, to write the null and alternative. The null is there is no difference. The alternative, since it's a confidence intervals are two sample. And so this means it'd be the same as having a not equal, right? But this was not required. But P1 is the true population proportion of people paying by check in the express line. P2 is the true population proportion of people paying by check in the regular line. Conditions. Random sample for both is given. And it's reasonable to assume one line should not impact that of the other. And by the way, we needed two independent groups, so independent random samples. So I kind of compared two things together. Then we have n needs to be less than 10% of the population, 85 divided by 0.1. Reasonable to assume that more than 850 customers use the express line during the day or month or some point. 92 divided by 0.1 is 920. Reasonable to assume that more than 920 use the regular line. Both samples have to be large enough. Well, they tell us 10 paid with checks, so that takes care of that. And the Q in this case is going to be 85 minus 10. So 85 minus 10 did not. So 75 did not pay with check. In the regular line, 37 paid with check, so that's greater than 10. And then we have 92 minus 37, or 55, did not pay with checks. So basically, in both cases, we see that we're greater than 10. So both samples are large enough to use a normal approximation. Here's our formula, p hat 1 minus p hat 2 plus or minus z star. I'm going to go ahead and calculate z star real quickly off to the side. So second vars, inverse norm, parenthesis 1 minus 0.95, close parenthesis, divided by 2. And I end up getting a z star equal to 1.96. So z star is 1.96. That's what we'll plug in here. And I need to calculate p hat 1. Well, that's 10 over 85 is 1176. Q hat 1 minus that, so that's 0.8824. P hat 2, 37 paid with checks in the regular line out of 92, so 40%. Okay. So when we plug into the equation, p hat 1 minus p hat 2, z star 1.96. Here's p hat 1 followed by q hat 1 over 85. P hat 2, then q hat 2 over our sample size of 92. All right, so let's run this thing. So stat, test, 2 proportion z interval. We're gonna have to scroll down a while. And we get to letter B, 2 proportion z interval, x1. Well, that was the 10 that paid by check in the express line out of the 85 customers. In the regular line, we had 37 paid by check out of 92. And we wanted a 95% confidence level. Please note, X and N must be whole numbers. If they're not, round them. So we end up with negative 0.4059 and negative 1.632. And here's what we can say. Let's look at our estimate. P hat 1, this was express, this was regular. So obviously, since we are negative, that means our regular had to be larger than our express. So more people are paying by check in the regular line. So here's what we can say about this. We are 95% confident that the true population proportion difference between paying by check and express and the regular lines lies with this in this interval. All right. In repeated sampling, we expect that our method will capture the true population proportion difference between paying by check and express and regular line 95% of the time. Make sure that you go in the order when you write these, that you actually go in the order you subtracted. And we went express minus regular, so I went express and regular. And probably would have been better if I would have put paying by check and the express minus the regular 95% of the time. And if we notice, 0 does not lie within the interval. So consequently, we can say the difference in the two lines is significant. Because the interval is negative, we know that there is a greater proportion of people paying by check in the regular line. All right. And once again, those who pay by check in the express line are inconsiderate jerks. Please don't stand in front of me. Okay, just kidding. All right, so that's scenario number 1. We'll do scenario number 2 on the next video. All right, thank you.